Assalamualaikum and hi. My name is SITI SYUHAIDA binti NORDIN, student ID 2021820062. My supervisor is Encik Muhammad Nizar Yusof. Welcome to my thesis presentation to all my panel and my viewers. I'm going to present my Viva titled Antimicrobial Properties of Piper Betel Leaf. This is the outline that I will present after this. We will start with the first chapter, which is Introduction. Piper betel leaf, or known as SYUHAIDA, are used to treat various health conditions, traditionally like bad breath, conjunctivitis, headache, itching, gum swelling, cuts and injuries. The efficiency of active compound present in betel extract like antibacterial, antifungal, antioxidant and anti-cancer effect has been reported by many pharmacologists. Betel leaf can also be used as antiseptic to remove pathogen from the skin. Moving on to problem statement, there are growing number of individuals that are susceptible to microbial infection. Modern medication could also have side effects such as drug resistance and allergic reaction. They are also expensive and less accessible compared to herbal-based treatment like betel leaf. Question rise from this research are first, what is the optimal solvent concentration to prepare extract from Piper betel leaf? Second, how to evaluate the antimicrobial activity of Piper betel extract? And what are the active compound present in Piper betel extract? So the objective of this study are first to determine the optimal solvent concentration for preparing an extract from Piper betel leaf. Next is to determine the antifungal and antibacterial activity of Piper betel extract using Kibri-Burgess diffusion test and to identify active compound in Piper betel extract using GCMS analysis. The significance of this study is to enhance our understanding of effective treatment for microbial infection, promoting the use of medical herbs like betel leaf. The expected outcomes is the antimicrobial properties of Piper betel leaf could offer a beneficial, cost-effective and accessible medical solution, making it is a promising potential for its utilization in various products with ensured safety and quality standard. Next, we go to the second part, which is literature review. A journal highlight the antibacterial and antifungal properties of Piper betel, where active compound like eugenol enhance antibiotic effectiveness. The extract and essential oil from Piper betel are found to be effective against multi-drug resistant and common pathogen. And there is a study of active compound in Piper betel and the effectiveness of the extraction vary with the solvent used, with ethyl acetate, ethanol, and methanol being the best for extracting antibacterial compound. There are also a research of antifungal activity of Piper betel against candidiasis infection, where methanol and ethanol extract of betel leaf show significant antifungal antioxidant, outperforming the standard drug in inhibiting Candida albicans growth. And the highlight finding that I found in a study of antibacterial activity of ethanol extract of betel leaf is that it were processed extract with ethanol and showed that betel leaf extract exhibit antibacterial activity against both gram-positive and gram-negative microorganisms. Next, we move to chapter 3, methodology. After I have collect, wash and grind the betel leaf, the second step is to prepare betel extract. 3 ethanol solution were prepared at concentration of 30, 50 and 70% by diluting 95% ethanol with distilled water in proportion of 180 ml using the equation M1V1 equal to M2V2. The grinded Piper betel was then extracted using the solvent extraction method and was refused for 6 hours. The solution was further concentrated using a rotary evaporator. Next, to prepare the media, potato dextrose agar, nutrient broth, and mula heated agar are autoclave at 121 degrees. After the media have been prepared, it can be used to grow culture. The fungus employed are Saccharomyces and Candida albicans, and the bacteria used are Staphylococcus and E. coli. The fungus were grown on PDA agar and were incubated for 2 days. After that, they were separated from the agar by using sterile water. The fungus then collected into bigger bottles before being separated onto mula-eaten agar plate. While for bacteria, they were grown on nutrient agar and incubated overnight. Once developed, they were transferred into bigger bottles containing nutrient broth. Mula-heated agar plate were then inoculated with the bacteria from these bottles. To determine the antibacterial and antifungal activity of the Piper betel extract, I used Curie-Bower-Disc diffusion test. For antifungal test, a sterile filter paper disc was dipped in 30% ethanol betel extract and placed on the MH agar surface in the first, second, and third section. The first section serving as a control used nistazine. These steps were repeated with 50 and 70% ethanol betel extract solution. For antibacterial test, the steps were similar but involved replacing the sample with bacterial culture of Staphylococcus and E. coli, and the control was substituted with ampicillin. And through the use of GCMS instrument, the active compound in Piper betel extract were identified. For statistical data, analysis of variance 1 with ANOVA was employed. P less than 0.05 was considered to be a significant statistical difference, while the null hypothesis is different solvent concentration does not give different antimicrobial activity, and the alternate hypothesis is different solvent concentration will give different antimicrobial activity. Next is Chapter 4, Result and Discussion. For the characterization of piper betel extraction, 70% ethanol solution has darker color, more viscous, and has strong pungent aroma due to high concentration of essential oil. For 50% ethanol solution, it has moderate extraction of pigment and aroma. And 30% ethanol solution has the lightest in color, least viscous, and mild aroma. For fungal colorization, the culture has yeasty odor and the shape is round and smooth. For Saccharomyces, the colonies were moist and rich in color, while Candida has white creamy color and pasty of colonies. For bacterial culture, they were white colonies. E. coli has sour odor, slightly raised colonies, while Staphylococcus has mild musty odor and the shape is round and convex colonies. For the antibacterial activity on piper betel, the summary of inhibition zone of E. coli is the p-value is 0.02 is less than 0.05, and the summary of inhibition zone of Staphylococcus is the p-value is 0.006 is less than 0.05, and for the antifungal activity on piper betel, the summary of inhibition zone of Candida albicans is p-value is 0.005 less than 0.05, and the p-value for Saccharomyces is 0.007 less than 0.05, and all the p-value of microorganism is less than 0.05. Therefore, we will reject the null hypothesis. We could say that there is sufficient evidence to conclude that different solvent concentration result in different antimicrobial activities. The compound identified by GCMS analysis including the percent area, neophytalin, phytol, rubicin, squalene, and vitamin E. Discussion for E. coli, the inhibition zone measured 7 mm at 30% concentration, increased to 9 mm at 50% and further to 11.67 mm at 70%. According to previous study, ethanol extract of piper betel at a concentration of 4 mg per ml, the inhibition zone of E. coli was 18.50 mm. The results show that different concentration of solvent give variable degree of bacterial inhibition, while the average diameter for Staphylococcus bacteria was 6 mm at 30%, 6.67 mm at 50%, and increased to 10 mm at 70%, indicating a moderate antifungal effect. The study report inhibition zone of ethanol extract of piper betel against Staphylococcus was 11.30 mm for 75%, 10.62 mm for 50%, and 10.03 mm for 25%, suggesting that higher solvent concentration enhanced the antimicrobial effectiveness. For antifungal activity, increasing concentration of piper betel ethanol extract result in a larger inhibition zone for Saccharomyces with 5.33 mm at 30%, 6.67 mm at 50%, and 7.67 mm at 70%. A study report an inhibition zone of 14.07 mm for a concentration of 50 ml piper betel against Saccharomyces. This suggests that higher concentration of piper betel extract enhance microbial effectiveness. For Candida, the finding indicate that higher concentration of betel ethanol extract result in greater antimicrobial activity against Candida. Specifically, at 70% concentration achieved the largest inhibition zone of 14 mm compared to 5.67 mm at 30% and 8.67 mm at 50%. This trend is consistent with a research which found an inhibitory zone of 8.22 mm using a 35% ethanol extract. This result suggests that increasing the concentration of the ethanol extract enhances its effectiveness against Candida albicans. And we have arrived at the last chapter, conclusion and recommendation. The conclusion is the optimal solvent concentration for preparing an extract from piper betel is 70% ethanol, which enhance the antimicrobial effectiveness. Piper betel extract show antimicrobial activity against both bacteria and fungal, as evidenced by the clear zone of inhibition observed in the Kirby diffusion test. At 30% ethanol concentration, the inhibition zone was smallest diameter at 5.33 mm, indicating limited antimicrobial activity. At 70% ethanol concentration, the inhibition zone was larger and the highest diameter was 14 mm, show microbial effectiveness. GCMS analysis of piper betel extract revealed a rich phytochemical profile, including compounds such as phytol, rubicin, squalene, and vitamin A, which contribute to antimicrobial properties. My recommendation for this study is to promote the benefits of piper betel through educational campaign could offer sustainability and cost-effective solution for managing microbial infection. And further study are needed to improve the effectiveness of herbal medicine like piper betel, thereby facilitating its practical application. Next is my references that I use for this presentation, and thank you for watching.